Okay, 211, we're going to talk about special derivatives. So to review for some of our answers, we are going to do the log properties. So natural log of 1 is something you should memorize. It really means the log base e of 1. So that's asking you e to what power gives you 1? 0, okay? That shows up occasionally, especially with tangent slopes, okay? The product rule, you take the natural log of the first and the natural log of the second. This also works with log. Power rule, you bring the number down in front, and most of the time you'll see this as an answer, so you're actually going to be using this to help simplify it for your answer to match the multiple choice. And the quotient rule with subtraction. Okay? So let's start doing some of the derivatives. So there's 3 different types. What I want you to notice about the third one is there's absolute value bars. So for this class, I'm not super picky. You cannot take the natural log of a negative number, so to be technically correct, we should have absolute value bars on our answers. I forget this and I just leave it off. So if you see this on an answer, just don't be thrown by it. Pick it, okay? X, we're going to start off with if it's just X, but you notice the problems get more complicated. So this is called the inside. And I just remember it's 1 over the inside, okay? Now, we're going to start moving on to more complicated functions. And so we always let the inside be a u quantity, and that means that it's more than just x. So when we take this derivative, it's actually going to be 1 over the inside, and then we need to multiply by the derivative of the inside. So I write that as du, but remember that really does mean u prime. It just flows nicer to say 1 over u du, okay? But they're being multiplied. So let's try example 1. So if I want to find the equation of a tangent line, this is going to be my u quantity. And I never memorized the first one because the 1 over u works for every function. So our derivative is going to be 1 over the inside, and then we got to multiply by the derivative of 2x, which is 2. Okay, so we're going to simplify, and our derivative is just 1 over x. So to find our tangent slope, we've done this before, we know x equals 2, so we get 1 over 2. Now, we don't have the point, but I know x is 2, and so we plug that 2 into the original, which is just going to give you the natural log of 4. Don't use a decimal. This would be a no calculator question, and the natural log of 4 doesn't simplify. So our equation will be y minus y equals mx minus x. And for our purposes, that's a great answer. Okay? All right, let's look at number 2. I'm going to do this problem the way most students will. So 5 is our u. So our derivative is 1 over 5, and then the derivative of 5 is just a number, so it's 0. Which really simplifies to say, oh, our derivative is 0? That's kind of weird. But let's look at what we actually had. Natural log of 5 is just a number, and we learned the derivative of any number is 0. So that's why it should make sense. All right, let's move on to number 3. You need to recognize that this is a product, so this is going to be 1, and this is going to be 2. So our derivative is 1. The derivative of natural log is 1 over its inside times the derivative of x, which is 1, plus 2. And then the derivative of x squared is 2x. So let's simplify. We can reduce the x's. Can't really do much here, so I'm going to put the x in front so it doesn't get confused with the inside of natural log. Remember, you can't change that. And this is an okay answer, but typically they'll take a common factor of x out. And so now that actually opens it up to where we can do the power rule. And they might do this, they might not. You really just have to be flexible. So 1 plus, this would be the natural log of x squared. Okay? All right, I think we've got one more. So find the second derivative of natural log. So I'm going to get 1 natural log of x. Our first derivative is 1 over the inside times the derivative of the inside. Our second derivative, well, you have two choices. You can do a quotient rule, or we can change this to a power and do a power rule. Power rule is always going to be faster than a quotient rule, but it's really just what you see. So I'm going to bring this down and subtract 1 and rewrite our answer without negative exponents. Okay? All right, we've done e, but they were all just basic e functions. So now that we've introduced the idea of u, we can be more complicated and have a little more fun. So remember, e is its own derivative. So the way it works with u is you still copy down the original problem, and then you have to remember to take the derivative of that exponent. Okay? So we got some things going on here. So let's look at the first one. Our derivative, well, we rewrite the problem, and then we multiply by the derivative of 2x minus 1, which is just 2. And there's not much you can do. Typically, you'll just put the number in front, so it looks a little nicer. All right, our second problem. This one, because I try to avoid the quotient rule just because it's time consuming, we're going to rewrite this with a power. So when we take our derivative, it's a little faster to do. So e to the u, and notice I'm going to copy down the original problem. And then when I take the derivative, that's when I use the power rule. So we bring that down and multiply and subtract 1. Now, there's not much we can do here. This is a negative power, so remember that needs to go in a denominator. We usually put the 3 in front. They might, it is really just hard to say. They might also, because this is a negative, they might move this one down as well. Just be flexible. I mean, they're all good derivatives, okay? All right, example number 3. We need to recognize that this is a product rule. So 1 and 2. So 1, d2 is e to the u times the derivative of its exponent plus 2, d1 is a power rule. Now with e, we typically have two terms and we want a common factor. So we can divide out a 2, we can divide out an x, and we can divide out an e to the 4x. So I'd be left with 2x. All of this gets reduced out, but you still need that placeholder. Okay? All right, we got 2 last special functions, and these are really the last 2 special derivatives, and then we learn 1 special derivative type. That's pretty important, but that's in Unit 3. Now, a, what you're going to recognize is a is a number, like 5 to the x. So a to the u, it's a long one. It's a to the u. It also has its own derivative, but it's also multiplied by the natural log of a, and then you have to take the derivative of the exponent. So a to the u ln a times du. It's a long one. The good thing is we don't really use this outside of derivatives, so for this section you'll memorize it and then you probably won't see it again. Okay? So we get a to the u, so 5 to the x, the natural log of 5, and then the derivative of x is u. Now, with natural log, sometimes you can make this number be the exponent, but a 1 doesn't change anything. So this really is our derivative. And it looks messy. There's just nothing you can do about it. Sometimes people put that in parentheses. All right, let's look at number 2. There'll be a little bit we can do here. So here's my a, here's my u. So a to the u times the natural log of a times the derivative of u. Okay? Now, we're going to leave the 2 to the 3x alone. order of operations when you multiply, I can put that 3 in front. And so what happens is that can now, with our log property power rule, we can bring that up as an exponent. So we get 2 to the 3x times the natural log of 2 cubed. And since that's just a number, you want to do 2 cubed. So 2 to the 3x times the natural log of 8. And that's probably what you're going to see, but be flexible. All right, the last problem is going to be an equation of a tangent line. So recognize this is a product rule. So our derivative is 1. d2 is a to the u natural log of a times du plus 2, and then d1 is a power rule. Now I don't do any cleaning up when I want to find tangent lines. So I want to plug that one in and just clean it up. So tangent slope, okay? So if we plug in a 1, we get 1 times 4 times natural log of 4, 4 times 2. So that's, I can make that my power, the natural log of 16 plus 8. This 8 is not inside a log, so I cannot add those together and say 24, okay? That's as simplified as this slope gets. Our point, we need to find. So 1, and I need to plug 1 into the original. So 1 times 4 is 4. So our equation is y minus y. Now our slope is kind of complicated, so I would put that in a parenthesis. And then x minus x. And distributing isn't going to make this look nicer, so I would leave your answer just like that. Oop, one more I lied. Second derivative. So that's a to the u. So our first derivative is a to the u ln a times the derivative of the ux. There's really nothing we can do. But what you recognize is the natural log of 3 is just a number, so I'm going to put that in front. But remember, that's just a number. So when you take the derivative of numbers being multiplied, it just carries over. So I'm going to write that over here. So the coefficient will stay, and then it's another a to the u derivative. So a to the u natural log of a times du. And you can't do much, but these are the same, so it would be like 5 times 5. So I'm just going to write that as the natural log of 3 squared. You might also see that as this, but this is good enough. All right, our last special derivative is log. And so I memorize this by, it's 1 over, it's called ulna. So u times the natural log of a. It's not all one word. And then we always multiply by the derivative of u. So 1 over ulna times the derivative of the inside. All right, so let's look at number 5 and 6. And you typically don't do tangent slopes with this. You just find the derivative, okay? So I'm going to write it up here as a refresher. So 1 over u natural log of a times du. So remember, this is a and this is u. So our derivative is 1 over cosine, the natural log of a, which is 10, and then the derivative of cosine is negative sine. Now, natural log is base e, so we can't really simplify the natural log of 10. I can't do sine over cosine. So I get negative, I'm going to put the negative with the numbers, 1 over the natural log of 10, because those are all numbers, and then sine over cosine is tangent. All right, let's do number 6. So we've got a and u, that 3 is part of it. So our derivative is 1 over u, natural log of a, and the derivative of u. Now this time we can reduce the 3's since they're being multiplied. And so we get 1 over, it really doesn't matter. Since this is a number, I'm going to put in parentheses though, because we don't want it to look like the x is inside that natural log. And that's it. All right, I know this has been another long section. It's a lot of information. So go ahead and try your homework practice. Let me know what questions you have, okay? Good luck.